This video covers mirrors. So just like in lenses, concave mirrors have this curvature to make it concave, and then we have convex, which we'll see later. The center of curvature also equals 2 times the focal length, so again, remember this equation. And this particular mirror are the types of mirrors that you see on the right side of a car. And we'll see why in a bit. For concave mirrors, if our light rays come in parallel, they are going to go through our focal point, again, meaning that they are convergent. But the other type of mirror we have is a convex mirror. Now here, we're looking at our object on the left-hand side, so we still have our object over here. Our light rays are going to come in parallel to it, and then when they do hit that mirror, they're going to diverge, meaning it's going to go off away from our focal point. But if you backtrace that ray, it still goes through our focal point. But again, for these types of mirrors, the focal point is behind the mirror. Now the measurements are still going to be the same except for one exception. Mirrors are actually cut only from one sphere, so they're going to only have one center of curvature. This is going to either be in front or behind the mirror. The sign conventions are also the same, except for a positive converging lens was convex. Now a positive converging mirror is going to be concave. They're opposite. And a negative diverging lens is concave, but a negative diverging mirror is convex. Again, opposite. But the equations, again, are still the same. Now we're going to run through a couple of examples. For these, you just need to sketch out the picture because, again, we're going to be doing these in class. The most important part is focusing on this bottom section here. So here we have an object that is beyond 2 times the focal length, okay? Again, beyond the center of curvature. This is a concave mirror. Again, you see that curvature here. Here the light rays are going to come in parallel and then again go cross through our focal point. Here it's going to go through our focal point and then come out parallel. Where they intersect is where our image will be located. This image is inverted and real because it's on the same side as our object. When our object, which is this one here, is located at 2 times the focal point, our image will be located at 2 times the focal point. But again, this one is still going to be inverted. So that means the math is going to give you a negative value. As you move in between the two F and F, our image starts to move away and it starts to magnify. So again, the math is going to show you a negative value here. It's still a real image because it will always appear on the left-hand side of the mirror. Now remember, when we do the math, we're going to see a magnification greater than 1. This tells us that it is larger than our original object, which is the top one here. Now for this one, when you have your object located at your focal, you can still try drawing your lines parallel and then through your focal, and then you can draw the other one from the object through the focal, and you're going to see that they don't intersect at any particular point except here, but we will not create an image there. So another line that you can draw is starting from the top of your object and through your center of curvature. Then you're going to see that these two lines are parallel, and when they are parallel, that means that you are not going to have an image be created, or your image is located at infinity. So here you have another situation. Now my object is inside of my focal length. We're going to draw the first one parallel, then through our focal, and then you're going to draw the other one to go through our focal, and then we're actually going to backtrace it. Even though my mirror doesn't go all the way up until this point, you can still draw your line up until that point, and then when it hits that mirror, it's going to go parallel. But now you see that these lines, although they're not intersecting, they also don't look to be parallel. So when that happens, again, you're going to backtrace it, and you see that they do intersect at another point. Now, if this is hard for you to imagine, you can also try drawing the third ray that we talked about in the previous example. So again, starting from the top of your object, you're going to go through your center of curvature. Notice that these lines are not parallel, and then backtrace it. So where they all three intersect is, again, where your image will be located. In this case, it is a virtual image because it's on the right-hand side. This image cannot be projected onto a screen. And then finally, we have our last example where we're dealing with a convex mirror. So with a convex mirror, we do have a divergent mirror, which means that the focal is a negative focal located on the back of the mirror, even though this is the reflective side. So this is my object on the left-hand side. I'm going to draw my first line that's parallel, and then when it hits that mirror, the light diverges. We are going to start from the top of the object and go straight through until we hit the center of curvature. Now, actually, you can still draw the other ray that we've been drawing this entire time, the second ray, meaning that we're starting from the top of our object. We line up to go towards our focal, but when we hit the mirror, we still travel parallel. So when that happens, you're going to see again these lines aren't parallel, so they must intersect at some point. So then we can backtrack it or backtrace it, and you see where they do intersect, which is going to be behind the mirror, is meaning it's creating a virtual image. It's on the right-hand side or the far side of this mirror.